The head did not speak, it only breathed. That, witnesses would later say, was the most unsettling part. The eyes blinked, the nostrils flared. The tongue reacted to drops of liquid placed upon it. Somewhere beneath the cloth, unseen tubes pulsed with borrowed life. The body that sustained those motions was not its own. In a laboratory far from public view, within a nation that believed history could be engineered by force of will, a question hung in the air, heavier than the smell of disinfectant. Where does life truly reside? This was not a philosophical seminar. It was an experiment. The Soviet Union in the middle decades of the 20th century did not merely seek to understand biology. It sought to conquer it. Nature, like society, was seen as something malleable, improvable, and ultimately obedient to ideology. If machines could be built to reshape economies and armies, why not the body itself? The experiment before them did not aim to heal. Not yet. It aimed to prove a point, that the most vital parts of an organism could be separated, sustained, and reassembled. That consciousness, whatever it was, might be independent of flesh as long as circulation continued. That death could be delayed, negotiated, perhaps even defeated. A severed canine head, kept alive through an artificial system, was not meant to be cruel theater. It was meant to be evidence. The men in the room did not cheer. Soviet science rarely did. They observed, they recorded, they adjusted valves and pressures. Success was measured not in applause but in minutes. How long the eyes tracked movement, how long the jaw responded to stimuli, how long the head remained alive. Somewhere outside the walls, the world was collapsing and reforming. Revolutions had hardened into regimes, purges had thinned institutions. War loomed, then arrived, then receded. But inside this laboratory, time moved differently. Here, life was measured in pulses per minute, oxygen saturation, and the delicate balance between coagulation and flow. The ethical question, should this be done, was never formally asked. In a system where the collective outweighed the individual, where sacrifice was both virtue and necessity, morality was often subordinate to progress. If the future of medicine required disturbing images, then disturbance was a price worth paying. Yet even among hardened researchers, something about this work unsettled them, not because it failed, but because it worked. The head responded. The experiment had crossed a threshold. If circulation alone could preserve awareness, then what else might be possible? Transplanted organs, reanimated bodies, entire systems rebuilt from parts. The line between life and death, once sacred and fixed, began to blur into something technical, a problem of engineering. The implications stretched far beyond dogs and laboratories, soldiers wounded beyond repair, leaders preserved beyond their natural span, humans redesigned, repaired, replaced. These thoughts were not written in official reports, but they lingered, unspoken, in the space between observation and imagination. Outside, history would later remember these experiments as grotesque curiosities, cautionary tales of science untethered from ethics. But at the moment of that first sustained breath, none of that was certain. All that mattered was the data and the proof that life could be moved. To understand how such an experiment became possible, how it was funded, justified, and pursued with relentless focus, we must step backward into a system that believed biology, like society, could be rebuilt from first principles. The story does not begin with a severed head. It begins with a state that believed nothing was beyond transformation. The Soviet Union emerged from revolution with a paradox at its core, a commitment to materialism paired with an almost mythic belief in human potential. Marxist ideology rejected metaphysics, insisting that all phenomena, including consciousness, arose from material conditions. For Soviet scientists, this was not limiting. It was liberating. If the mind was a product of matter, then it could be studied, manipulated, and perhaps preserved. Physiology became a favored discipline. Unlike genetics, which would later fall under ideological suspicion, physiology aligned cleanly with the state's emphasis on mechanics, systems, and observable processes. The body was a machine. Blood was a hydraulic system. Organs were components. This intellectual environment traced its lineage to Ivan Pavlov, whose work on conditioned reflexes had earned international acclaim and domestic reverence. Pavlov's laboratories established a tradition of invasive experimentation on animals. justified by the promise of objective knowledge. Suffering was unfortunate, but truth was paramount. By the 1920s and 1930s, this approach had become institutionalized. State-funded laboratories proliferated, tasked with expanding human endurance, improving surgical techniques, and exploring the limits of survival. The looming prospect of war intensified these efforts. If soldiers could be kept alive longer, repaired faster, or returned to duty despite catastrophic injuries, the strategic advantage would be immense. It was within this context that researchers began asking radical questions. Could organs be sustained outside the body? Could circulation be artificially maintained? Could life be extended beyond natural boundaries through mechanical intervention? One figure emerged as central to these inquiries: Sergei Brukhonenko. Working in the 1920s and 1930s, Brukhonenko developed an early form of a heart-lung machine known as the autojector. Its purpose was to maintain blood circulation and oxygenation during surgery, a revolutionary idea at the time. To demonstrate its effectiveness, Brukhonenko conducted experiments that would become infamous. Animal organs and eventually severed heads were connected to the machine. The results were undeniable. Tissues responded, reflexes persisted, life in some measurable sense continued. These demonstrations were not hidden. They were filmed, presented at conferences, and framed as triumphs of Soviet ingenuity. The message was clear: socialist science could achieve what others had not dared attempt. But Brukhonenko's work was only the beginning. By the 1940s, a younger generation of researchers, hardened by war and emboldened by technological advances, pushed further. Among them was Vladimir Demikhov, whose interests lay not in isolated organs, but in whole systems. Demikhov believed that complex surgical reconstructions, multiple hearts, transplanted lungs, even combined organisms, were not only possible, but inevitable. The Soviet system enabled such ambitions. Ethical oversight committees, as understood today, did not exist. Experiments were evaluated based on results, not moral considerations. Animals were resources. Failure was acceptable. Persistence was mandatory. Institutionally, these projects were sheltered within military and medical research centers, insulated from public scrutiny. Secrecy was routine. Even within the scientific community, details were often compartmentalized. What was at stake was more than academic prestige. Success promised practical applications: trauma medicine, organ transplantation, and the management of catastrophic injuries. In a nation that had lost millions to war, the appeal was profound, yet the cost was high. Dogs, chosen for their size and physiological resilience, became the primary subjects. Surgeries grew longer, more complex. The line between experiment and spectacle blurred. As techniques improved, the question shifted from "can we keep tissue alive?" to how much of an organism can be separated and still function. By the late 1940s, the stage was set for experiments that would push this logic to its extreme. The idea of transplanting a head, or creating a two-headed organism, was no longer dismissed as fantasy. It was framed as a technical challenge, solvable with sufficient skill and persistence. The system encouraged this escalation. There were no incentives to stop, only to succeed. And so, in quiet laboratories far from the eyes of a world rebuilding itself, preparations were made for experiments that would test not only surgical limits, but the very definition of life. The early experiments did not begin with spectacle. They began with plumbing. Circulation, Soviet physiologists understood, was the foundation of life. Without blood flow, organs failed. With it, even separated tissues could persist. The challenge was not philosophical, it was mechanical. Tubes had to be the right diameter. Pumps had to mimic the rhythm of a heart. Blood had to remain oxygenated and unclotted. In the 1930s and early 1940s, laboratories refined these systems through relentless trial. Dogs were anesthetized, connected to external circuits, and monitored as researchers adjusted flow rates and pressures. Failures were frequent. Clots formed. Vessels collapsed. Hearts fibrillated. Each failure produced data. Gradually, survival times increased. Minutes became tens of minutes. Reflexes returned after reconnection. Organs resumed function. The body, it seemed, was more tolerant of intervention than previously believed. This success bred ambition. Researchers began experimenting with partial transplants, an extra heart connected to the circulatory system or a lung grafted alongside existing organs. The logic was incremental. If one heart could support two sets of tissues, why not more? If circulation could be shared, why not organisms? These procedures were painstaking. Vessels were sutured by hand. Anesthesia was crude by modern standards. Infection was a constant threat. Yet occasionally the animal survived, long enough to demonstrate proof of concept. Ethical considerations eroded gradually, almost imperceptibly. Each successful intervention normalized the next. What had once seemed unthinkable became merely difficult. Within this environment, Demikoff's ideas took shape. He viewed the body not as an indivisible whole, but as a modular system. The head, in this framework, was simply another component, albeit a complex one. The hypothesis was stark. If the brain required only oxygenated blood to function, then it could be sustained independently of its original body. Motor control would be lost, but awareness might persist. Reflexes might remain. Sensory processing could continue. Testing this hypothesis required an experiment that would shock even seasoned researchers. Preparations were meticulous. Donor and recipient animals were selected for size compatibility. Surgical teams rehearsed procedures repeatedly. Equipment was checked and rechecked. Failure at this scale would not merely set back the research, it would challenge the underlying theory. The first attempts were chaotic. Vascular connections failed. Blood pressure dropped precipitously. Neurological responses were inconsistent. Some animals died immediately, others survived briefly, then deteriorated. Yet fragments of success appeared. Eyes responded to light. Tongues moved when stimulated. The data suggested that the concept was viable, even if execution lagged behind theory. Each incremental improvement emboldened the team. Techniques were refined. New suturing methods developed. Blood compatibility was considered. The surgeries grew longer, more controlled. Observers noted a change in the laboratory atmosphere. What had once been exploratory became obsessive. Researchers spoke less about whether it should be done and more about how to do it better. The experiment acquired momentum of its own. The dogs, meanwhile, were reduced to variables, identified by numbers, not names. They were anesthetized, operated on, observed, and, when necessary, discarded. Emotional distance was not just encouraged, it was required. By the late 1940s, the procedures had stabilized enough to attempt a more dramatic configuration, the attachment of a living head to another animal's body, creating a shared circulatory system. This was not framed as monstrosity, but as demonstration. If successful, it would prove that the brain's survival depended solely on circulation, not bodily integrity. The team understood the implications. Organ transplantation, once a dream, could become routine. Traumatic injuries might be bypassed rather than repaired. In theory, any organ could be replaced, any system rerouted. The ethical cost remained unspoken, but it accumulated nonetheless. Some researchers began to experience unease, not enough to stop, but enough to haunt them. The sight of responsive eyes, disconnected from agency, lingered long after shifts ended. Still, the work continued. The final preparations were made. The laboratory was quiet, controlled. Instruments were laid out with precision. This time the goal was not incremental improvement. It was to cross a line. The decisive experiment unfolded not as a single moment, but as a sequence of irreversible choices. 2 dogs were anesthetized and prepared simultaneously. One would serve as the host, the other as the donor. Surgical teams worked in parallel, coordinating every step. Time was critical. Ischemia, the deprivation of blood, would doom the procedure if delays occurred. Incisions were made. Major vessels were exposed. The donor's head was separated with deliberate efficiency, immediately connected to the host's circulatory system through carefully sutured arteries and veins. External pumps assisted the transition, stabilizing pressure and flow. For a moment, nothing happened. Then the monitors shifted. Blood flowed. Color returned to tissues. The head exhibited responses, subtle but unmistakable. Reflexes persisted. Sensory reactions could be elicited. The experiment had succeeded, at least technically. What followed was observation. Hours stretched into days. The host body functioned, burdened by the metabolic demands of two organisms. The attached head remained responsive, though entirely dependent. It could not control the host. It could not vocalize meaningfully. It existed in a state that defied easy categorization. Researchers documented everything: feeding responses, reaction to sound, changes in blood chemistry. The data was unprecedented, yet cracks soon appeared. Immune rejection loomed, poorly understood at the time. Infection threatened the surgical sites. The physiological strain was immense. Despite these challenges, survival extended far beyond initial expectations, long enough to demonstrate conclusively that a mammalian head could be sustained by another body's circulation. This was the point of no return. News of the experiment circulated within closed scientific circles. Some hailed it as a triumph, others recoiled, uneasy with its implications. Officially, the work was praised for its contribution to transplant science. Unofficially, it became a symbol of excess. Demikov pressed on, conducting variations of the procedure, refining techniques, extending survival times. Each iteration reinforced the core conclusion: life could be redistributed. But the cost mounted. Public disclosure was impossible. International reaction, if known, would be severe. Even within the Soviet system, tolerance had limits. As the post-war period progressed, priorities shifted. Resources were redirected. Political winds changed. The space race and nuclear research eclipsed biological spectacle. Demikov's work, once celebrated, became an embarrassment. Too disturbing, too controversial. The experiments did not end in dramatic exposure. They simply faded. Funding dried up. Publications were curtailed. The laboratories moved on. Yet the impact endured. Techniques pioneered in these experiments laid groundwork for modern organ transplantation. Heart-lung machines evolved. Surgical methods improved. Immunology advanced, addressing problems that had plagued the early work. The two-headed dogs became legends, stripped of context, reduced to shock images. The scientific motivations, however flawed, were forgotten. The ethical debates remained unresolved. In the end, the experiment collapsed under the weight of its own implications. It had proven too much. It showed that science, unrestrained, could trespass into realms it was unprepared to govern. That technical success did not equate to moral clarity, that the ability to do something did not justify its doing. The laboratory lights dimmed. Records were archived. Silence returned. But the question remained. In the decades that followed, Soviet head transplant experiments occupied an uneasy place in scientific memory. They were neither fully denied nor openly celebrated. References appeared obliquely in technical papers on transplantation, stripped of their more disturbing details. Internationally, as ethical standards hardened and oversight committees emerged, such experiments became unthinkable. The concept of informed consent, animal welfare regulations, and bioethics as a discipline reshaped medical research. What had once been permissible became prohibited. Demikov himself lived to see aspects of his work vindicated in unexpected ways. Heart and lung transplantation, once fantasy, became routine. Surgeons cited his technical innovations, if not his most extreme experiments. History, it seemed, had selectively forgiven, yet the moral discomfort never vanished. The experiments forced a confrontation with a question that remains unresolved. Is life merely a function of systems, or is there something irreducible about the whole? If circulation alone sustains awareness, what defines identity? Where does the self reside? Modern medicine continues to grapple with these issues. Life support technologies blur the boundary between living and dying. Transplantation challenges notions of bodily integrity. Neural interfaces raise questions eerily similar to those posed in Soviet laboratories nearly a century ago. The difference lies in restraint. Today, the legacy of those experiments serves as a warning rather than a blueprint. They remind us that progress without ethics can become distortion, and that the pursuit of knowledge, when detached from compassion, risks becoming its own form of violence. The dogs in those laboratories did not choose their role. Their suffering was justified by promises of future benefit, a calculus that remains deeply contested. As science advances, the temptation to push boundaries will always return. New technologies will invite old questions. The past does not forbid us from exploring, but it demands that we remember. Because the most dangerous experiments are not those that fail. They are the ones that succeed without teaching us when to stop.